7 meter 500. Does it take me to the center? Where does it take me to? To the center. There you can see. Take me to the center of those beams. Right. So it takes me to the center of the beam. So what is the size of those beams there? My size is 300. My size there is 300. So take it to the half. It's 300 divide 2. That gives me 150. And I've got to multiply that by 2 again. So, in effect, it is the 7,500 minus, no man, what minus? The 7,500 plus 2 times 300 divide 2. That gives me 7,800. All agree with that? You see what I've done? What I've done, I've taken that 7,500 that is across there. 7,500 that's across there. And I said that I need to add that and I need to add that. So I know that this is 300. So I need to find the half of that 300 so that I can add that 150 and add that 150. So this is 300 divided by 2 gives me 150 times 2 gives me 300. So it's 750 plus 150 plus 150. And that gives me my 7,800. And my 7,800, but is that correct now? No. So you're talking rubbish. It must not be plus that, it must be minus, because I'm working from there to there. So it will be 7,500 minus 300, and that gives me 7,200. Do you agree with me now? So it is 7,200. So the length there for my purple beam that I have to do for that and that and that one then is 7,200 or 7.2 times 0.85 times 3. Right? So I now would have covered that and that. That is what I would have covered. But when I look at this, I have covered, but what about that section there? And that section there, all the way around. Shall I measure this here? Shall I measure this here with my sides and soffits of beams, or shall I measure it at another time? I can, of course, measure it right here. I can measure it here, whereby I would then, okay, if I can then just say the other one was, we said 7 meters 600, right? 7.6 times 0.85, and that was times 2. My beams in the orange. Right? I can now go in and I can say, right, it is 7.2. No, do it elsewhere. I can say 7.2 by 0.13 by 2, and I can say 7.8 by 0.13 by 2. And that will then take care of that section at the edge of my slab all the way around. Are we happy with that?
Excuse me, sir.
Yes, Manolo.
Just want to ask, in practice, would you separate the two, or would you just measure it straight through?
When you say we talk about the two different slabs?
Yes, I'm just talking about because this part of the formula, I think you just separated it, you calculated the first for the beam, and then you're coming back to calculate this other part. I'm just asking, like, in terms of practice, would you?
No, you can look. Remember, Manolo, at the end of the day, whether you do it this way. Remember last week when we measured last week, we added the two, we added them together. We actually added that. There, we added that, and we then said that we added that. But we always learned that we do it from there, and then we add that section later on. Whichever way you do it, remember that when we do, let me just clear all of this here. Remember that when we now do, we will still from here, we still need to do an abstract. And when we do the abstract, what do we do in the abstract? We will then, in the abstract, add all of those that belong together. We will then add all of those where they have the same, where they would have the same description for the same place. We would add all of them. We would add all of them together. So that is just that is where we are insofar that is concerned. So whether you add it here or whether you add it a little later, it's immaterial. I'm just putting it together there because all of that refers to the 125 ribbon block slab. It refers to that section because when you go and look at the drawing, when you take this drawing, when we look at this drawing further, when looking at this section on the drawing, you would notice that in here that I have the beam there, but I have no beam that side. That side it's just the slab. Okay? That's just a slab. So I dealt with everything on this side where that refers to the beam, that refers to all of that. And that's why I've done it there. But you can keep it separate. You can come back later and you can measure that like how we've done it previously. It does not matter as long as we will bring all of those elements and all of those sections that belong together when we do the squaring and preparing for the bull. When we bring all of those together. I hope that answers your question, Madolo.
Yes, yeah. No, got it home, sir. I just thought it looked like faster to just combine, but yeah, I understand your reason now.
You see, so I'm showing different ways of how you can do it, and I'm showing that yes, you can do it there. You can keep it separately, or it all is entirely up to you as to where you want to do that in. Okay.
Understood, sir. Thank you.
Okay. So what I've done, I've now just done everything over there with the beams. Because on this side, we have no beams. Okay? That's why we have no beams. So we finish everything on that one side. And because the two slabs are separate, are different, the two slabs are different. When we also go in and we will now measure the slab for that to that section. We will now measure that slab and we will indicate on that slab, we'll say reinforced concrete 20 MPa 90 millimeter stone in slabs, beams, and inverted beams. And this time we will now underline the slab section. But we also need to take into account, if I can go back, just to my previous section, the category of where my beams would fall in. The category of where my beams would fall in, I would notice that the height there is 300. Okay, that is from reduced level. The height is 300, and I know that my beams go through that they are 400, so it will fall in the category of exceeding 1.5 and not exceeding 3.5 millimeters. 5 meters from bearing level. What is my bearing level? That there is my bearing level. The bearing level is the ground level, and it's 3 meters, so it falls in the exceeding 1.5, not exceeding 3.5 meters from my bearing level. For the columns, we measured my bearing level. Where do we measure my bearing level from for the columns? We measure that from there. Right. And now we're looking at the slab. And we look at my slab, and we look at where it is that we will be working from. I will measure my slab over my beams, and I have my dimensions here. We said that dimension there is 7,500 plus 300. No, not deduct. 7,500 plus 300, so it's 7,800, and we multiply that by 7,600, which is made up of 3,800 plus 3,800, which gives me 7,600. And with my thickness there, 0.13. So I have 7.8, I have 7.6. Is that correct? Oh, no, I'm wrong. I've made a mistake here, guys. An elementary mistake. All the way back to where we started with the beams. This here, and you guys know that I am quick to admit when I've made a mistake. The dimension there is, yes, it's a 3. If I go in and I blow this up, I'll just pick this up here now. If I blow this up, it shows that this also goes to the center, meaning that I would also have to add 150, 2 times 150 on there. So I need to say 2 times 150. That then brings that to 7,900. And my apologies for that, guys. That dimension there is 7 meter 900, and it means that the overall length here would then be 7,900 multiply 0.85 times 2, that is for the beams, and also the 7.90 multiply 0.13 times 2. My apologies, guys. I hope that you understand what it is that I'm pointing at here. I have not taken the dimension there shown that the dimension goes to the center of the beam, and I disregarded that. I did not take that into account. You guys with me? You guys see what it is I'm talking about? Please show by a thumbs up or raise your hand if you have a query if you're not happy with that. All right? Thank you, guys. My apologies once again. So my dimension for my slab, the reinforced concrete slab 20 MPa in slabs, beams and inverted beams will be 7.9 by 7.8 by 0.13. And we then have to look at the formwork to that. The formwork to the soffit of my slab, including propping up, exceeding 1.5, not exceeding 3.5 meters high, would therefore be, we would then use the dimensions that is shown as 7.9 by 7.8, and we would then deduct, we'd go in and we'd say deduct ditto. And what will that ditto refer to? The ditto, because we will be measuring over there, that is where our measure come from for that dimension there. It is for the section, but I also need to deduct, and I'm going to change the color of what it is I need to deduct. I don't need to deduct. I need to deduct that. Whatever is marked in purple, I need to deduct that. Why do I need to deduct that? Because I have already measured the formwork to the sides and sockets of my beams. So I now need to deduct that from my dimensions of my slab, because otherwise I'll be over measuring. So what are my dimensions that I do have? What we will be deducting, let me do that in red. What I will be deducting is the following. It will be the 7.9 by 0.3 by 2, and it will be a 7.2 by 0.3 by 3. That is what I will be deducting from this dimension here. The dimension for the soffits of my slabs, that is what I will be deducting. All clear on that. And my dimensions there would fall in the category of exceeding 1.5 and not exceeding 3.5. Okay? That is that. I don't need to measure the ribs because this is a ribbed and block slab. It is a ribbed and block slab, and the information given to me I will find over here. It tells me that that is a ribbed and block slab. No, that's not a ribbed and block slab. That is just purely a straightforward concrete slab, reinforced concrete slab. So when I go over to my other side, to my next side, and this is where I would notice the following that I have over here. My trough slab. So now you see we have three different setups of slab. So when we go in and we measure for my trough slab, we will go in and we will have a look at how best would be to measure this. We state this that it will be the following in trough slabs. The following in trough slabs and that would refer to the reinforced concrete in this slab. That slab and the thickness of that slab, that is 300 millimeters. In that slab, and when I show this on the drawing, it will refer to that slab over there. In my trough slab, And when I now go in and I measure that, so my description would read reinforced concrete 20 MPa in trough slab, including beams and inverted beams. I have to state that. So my overall dimension for this slab here would be, when I look at my dimensions and I blow this up, I'm sitting with the same scenario here, sitting with the same scenario where I now have to measure from there to the outside there. And again, it would now be 3,800 plus the 3,800, and then also plus the 300, because those dimensions take me to the center. And the same dimension to the other side, so it would be my 7,900 multiplied by my 7,800 and multiply by 300.
Excuse me, sir.
Yes, Padolo?
The 312, that is next to where you have circled your 3,800. The 312, what does it refer to?
Let's go in and have a look.
If you see where your two different slabs are meeting, there's a 312 over there. That gives you your centers. It's not 300.
Can you see my drawing there, Madolo?
312, yes, I'm asking about that.
That 312. Now, what does that 312 refer to? That 312 says that the distance from the center of this beam to the to the other side there is 312. Okay. What does that refer to?
Okay, the distance between the two centers of
it just gives you the distance between the two centers.
Yes, okay, sir.
Understood. See that? Because this beam is 300.
Yes.
You with me?
Yes, sir.
So that 312 is just there to show that it's a distance between the two centers.
Yes. And the beam on the other slabs, I see a 150 and the 200 there.
That's 150. That just shows the dimension. The 150. 150 and the 200, and that will be, remember later on where we will now start measuring between the centers of, when we measure for our troughs, to determine what those centers are, what we would add on either side. Remember that then comes into play there. And this here would form part of the solid section, and where we would stop with that solid section when we measure now for our trough slab.
Okay, no, understood, sir.
Okay? So that information is given there, given for us there to utilize a little later, right? So now,
understood.
I've got my slab thickness of 300. I've got my dimension of 7,900 and 7,800. I will multiply those with one another. But because I have these troughs here, all the way through, I will have to deduct that, right? But when I look at my drawing, I also notice something very, very, very peculiar on my drawing, which is not shown up here. But if I have a look at this drawing here, it shows me on this drawing that over there, I have a 100 by 75 nib. And that nib runs where? That nib runs all the way around there. You see that? So I've already measured my slab. I've measured my slab, but I also need to include the concrete to that nib. I need to include the concrete to those nibs. And how do we get to those nibs? I have a look at my dimension, and I know that this dimension here from there to the outside there is 7,900. So I need to add 100 millimeter for my nib. So it will be 8 meters multiplied by 0.1 and multiplied by 75, and we have 2 of those. If we rewrite those, it will be reflected as follows. It will be reflected as that. 2 times 8 meters for my nib times 0.1 times 0.08. And that will take care of that nib that side and that nib on the other side. I then go in between. What are my dimensions as I go in between? My dimensions going in between would now be as follows. For my vertical, it would be 7.8 by 0.1 by 0.08, and that will refer to that nib that goes in between. Okay? It's also concrete. Remember, it's the same strength concrete, it's the same size stone concrete, and it forms part of that slab. So, but now I need to deduct for these troughs. And I need to deduct for these troughs those troughs in there. And how do we arrive at those dimensions for those troughs? How do we arrive at those dimensions when looking at those troughs? I take my dimension and I have my overall dimension of 7 meter 800. Right? But all of you remember your question you asked me. Of that, the question you asked me of that 350. Right?
Yes, sir.
Now this dimension, you will have that all the way around your slab. If that is the slab, you will have that 350 all the way around with your troughs
as a soffit.
Almost like a beam that is being created.
Okay, now I see.
So that 350 would be all the way around. So what do? I need to deduct for the length of those troughs. So I have my overall length of 7,800, and I need to deduct, so it will be 7,800 and 2 by 350. Deduct that, it gives me 7. So the length of my trough is 7,100. The length of the trough is 7,100, and what is the dimension for that trough? What's the dimension for that trough? I now know that over there it is 420, and over there it is 600. So if I draw my trapezium, it will therefore be 420 plus 600 divide 2. That gives me 1020 divided by 2. No, oops, not that. It's not 600. It is 500. Why 500? Because at 600 takes me to the center and it shows that that is 100 and 100. So I will have to say 100 minus 2 times 50. That's in the center. That will give me so that is 500. So it's 920 divided by 2 gives me 460. Are you all with me with what I've said? Referring to this section over here, where the 100 shows me the width of the beam, and it also shows that the 600 goes to the center of those beams. So I need to get the dimension to there and there, which is then between the two blue marks, which is 500. So this is the 420 plus the 500 divided by 2 gives me 460. And when I show the deduction of what it is I need to do that, I've determined that it is 7.1, the length, multiplied by 0.46, and I have my depth there given to me as 225, and that is 0.23. But how many do I have? How many of those do I have? In order to determine how many we will have to show, in order for us to show how many we will have between that line and that line, I will have to deduct, or I will have to take my overall dimension, which we had as 7,900. I will have to deduct 2 by 350. That deals with that. And I would have to divide that by 600. So that gives me 700, it gives me 7,200, and I will have to divide that by 600. That gives me 12 troughs. Because I was not given how many troughs we have, I will have to determine that, and I can determine that because the 600 given there is given to us from center to center. If we were told how many, we could have used all those dimensions to add, like how we would have used that with our ribbed section. So it is 7,200 divided by 600, and it gives me 12. So my dimensions that I will be using here would be 7.1, 0.46, 0.23, and I would have my deduction of 12. So we have 12 troughs that I will deduct from there. Right? Let's go. So when I now work with that, I'm not done, and I've now sorted out the concrete that goes into my trough. For the formwork, I'm going to go out to the working for my formwork. Shows us there that it's formwork to the soffit of the trough slabs exceeding 250, not exceeding 500 millimeter thick, including the rib size of 100 millimeter wide. Where do I get that rib size of 100 millimeter wide? That is given to me it's given to me on the drawing that it shows as 100 millimeter wide by 225 millimeter high at 600 millimeter centers. So that tells me that that is 600 millimeter centers, including propping up exceeding 1.5 and not exceeding 3.5 meters high above bearing level. And I'll go in and I need to determine what this area is. I'll then have to work out exactly what the area is of this for the formwork. Because I can then see there that I take my 7 meter 800, which is my overall dimension, deduct the beam, if I can call it that, or the solid section all the way around, which is 350 by 2, it gives me 7100. And the 12 by my 600 gives me my 72 that I had. So meaning that it will be the 7 meter 200 multiplied by my 7 meter 100. Or I can of course also show that up as as it is shown over there, where I take my 7 meter 900 minus 2 by 350, just to show that that is how we've arrived at it. I can take my 7 800 minus my 7, as I indicated earlier. I have my 350 all the way around, and that is 7 900, and that is 7 800. So I deduct the 350 times 2 from those two. That will give me my 7 200 multiplied by my 7 100 for the formwork. Remember, it's important that we give the size, we tell what the centers are, what the height is, the rib sizes, and all of that when dealing with my formwork to my trough section. And we will also now, for the size of that rib slab or that trough slab, for the size of that, we will then have our dimensions that we would have. Now you see that it shows here 7 meter 900, which is 7 meter 900 multiplied by 0.3 by 2. Why 0.3? Why not 0.35? Anybody tell me why not 0.35? And why it reflects as 0.3? Anybody? Why do we have 0.3? It's very important for us to understand that why we're using 0.3. What were the dimensions that we had indicated for this trough? How did we describe this trough? We said that the trough, when we dealt with the formwork, it says that the rib size is 100. Right? So what do? Yes, we have that shown to us as 350. But where does it stop? Where does it start? What is that dimension there? It is 50 millimeter. Can you agree with me? Do you agreed with that is 50 millimeter.
Yes, yes, sir.
And what does that 50 millimeter form part of? It forms part of the formwork to the trough. Because we have 100 millimeter there. Because we have 100 millimeter there. Part of that formwork to the trough is $50 millimeter. It gives us 50 millimeter there. That in itself tells us that we have the 350 minus the 50 that leaves me with 300 as my width all the way around. Are you with me?
Yes, sir.
So what I mentions there, therefore, then refers to that, and what it then says is, on my horizontal, I would then have the 7 meter 900 multiplied by 0.3, and there's two of them, because the two of them would then refer to that and that side. The 7,900 times 0.3, there's two of them, and then we have 7,800 times 0.3. But where does the 7,800 come from? So 800 then therefore refers to what does that refer to? Is it not times 2? As I said, 800 not be times 2. Must it not refer to this side and that side? Must 7 or 800 not say times 2? Does it reflect times 2? Must it reflect times 2 if I have a look at this drawing here?
I think it should say times 3.
Times 3?
I think so.
No, let us have a look at this. What is my description there? It says the formwork to my trough, to the sides of my trough slab, will refer to that and to that. Now, where does that show on my drawing? Shows that my thickness there is 225 plus 75 gives me 300. So that is the formwork to the sides of that. And how do I do? What do I do? Where do I measure the formwork to the solid sections? Do I measure that? Have I measured the formwork to this here? Have I measured that formwork? I've not measured that as yet. So, when I deal with the formwork to the sides of my trough slab, it will be the thickness that we are given, that we know is 300, and it will be at 7 meter 900 there, and it will be 7 meter 800 that side. I've already measured that. That is done. We said that it goes up against the expansion joint, where we do not have to worry about measuring, but measuring the sides there, because that is already measured in over here, because that will go up against the existing slab there. So Formwork to the sides of my trough slab would therefore refer to the section on the side there only. That's for my vertical. Then as my formwork to my sloping sides of the troughs, and the trough size is 400, we indicate the trough size that we give. When I go back to my workings, the formwork to my sloping sides of my troughs with a size of 420 at the top and 500 at the bottom, and we're giving the height. And we've determined by our calculation earlier on that we have 12 of those troughs. That's for formwork to my actual troughs. We have the formwork to the soffit of the adjacent section. Now we're coming to it. Formwork to the soffit of the adjacent section. Adjacent flush surfaces, including the propping up, exceeding 1.5, not exceeding 3.5. We've already measured the overall dimension. So all we do is we take that overall dimension, we deduct the trough sides that we've measured. It's a 7.1 by the 7.2, and that is a deduction that we would then ensure that the remainder is then taken care of. Now for my ribs, or for my nib, the boxing out, we now need to measure the boxing out, and the standard system tells us measuring boxing out would be referred to as extra over. Formwork for boxing in formwork to soffit of the trough slab to form a splayed fillet, size 38 by 25, at the bottom of the ribs. Where on earth? What is it talking about? Extra over, formwork for boxing in, formwork to the soffit of the trough slab to form a splayed fillet, size 38 by 25, at the bottom of the ribs, and we also now measure 35 by 25 millimeters sawn South African pine splayed fillet plugged into the recess in the concrete L-square measure. What are we talking about? Let's go and see what it is that we are talking about. So let's see what it is we're talking about. If we have a look at over there, and I will blow that up, that tells me 38 by 25 millimeters splayed wood fillet. See that there? And that splayed wood fillet goes into each and every rib of my trough slab. That's where that description comes in, where we need to measure extra over for the formwork for the boxing in of those ribs, and it goes into each and every. You can see there where all over it goes on each and every rib or nib. Sorry, each and every rib. Now, how many troughs do we have? 12. Meaning that we have 12 troughs, and that we should have one more of this boxing in splayed fillet, because we had 12 troughs, and the 12 troughs would refer, like if you hold your hand out, you should see like the web between your fingers would be the trough, and the ribs would be your fingers. So if we have 12 of those, we would add 1, and that will give us 13 ribs or 13 splayed fillets that we would then encounter over here. So my dimension there would be, it would be my length that I've given, the length that I have arrived at from using the 7,800 and deducting the 2 by 350, which is 700, giving me my length of 7,100, and I have 13 of those that we have there for the boxing in. 13 of those with the extra over, measuring for the boxing in and also measuring the fillet that we need to allow for over here. Wait, not fillet. Why haven't I missed my... No, I put the wrong drawing. 400. Okay. Then between my two slabs, between my 125 and my 300 millimeter thick slab, we will now have our impregnated soft board. The soft board is the expansion joint between the two slabs. Why do we have an expansion joint there? Because for any movement that should take place, it should be taken care of. And I have the 12 millimeter impregnated soft board in expansion joint between the beam and the adjacent slab, not exceeding 300 millimeters high. That runs along the entire length of my slab, so the length there is 7 meter 800. Okay, and this is where things start becoming interesting now. Because going into and looking at my drawing and taking us back to last week to where we had measured the columns. I said that, and Madola also gave me the answer. I said that we would then keep these columns separated from these columns. You remember that? And you said that the reason for that is because of the cost. You said that when we cast columns on a higher level, it becomes more expensive. It becomes more expensive to cast columns over here than what it is to cast them down there. So, it means that we measure for the columns on the two different levels, we measure them separate from one another. Does that make sense? Makes sense for us to do that? To me, it makes a lot of sense. I think of Bob Marley's song, all this dread rock dust makes a lot of sense. So, I will now look at us measuring the columns up there first. And when we measure the columns to that top section, we now first and foremost need to determine what would the length of these columns be. What would those heights of those columns be? Because these columns would now be placed from that level on up. And I look at my drawing, when I look at my beams first, when I look at my drawing and I look at my beam sizes and I look at my slab at the top there, it tells me that I have a hollow block floor slab. Excuse me. I have a hollow block, and the thickness of that is given to me as 305. Thickness there is given to me as 305. The height of my columns is given to me as 300. Given to me as 300. But I now want to see what the section indicates, what the details indicate to me there. It shows there that I have 305, and I will then have to just work my columns that come below that, and that will be supported by the deck below. And how many columns do I have? I look at my drawing. I want to have to look, and I notice that I have I have 6 columns. All see the 6 columns. Where do I get that from? I see that I get shown that this is the roof plan down there. And I know that my column heights are 3 meters. My column heights are 3 meters. And what does that mean? It means that my columns will all be in the category not exceeding 3.5 meters from bearing level. What is my bearing level? My slab is my bearing level. So for my columns, first and foremost, I'll go in and I'll measure my rectangular columns not exceeding 3.5 meters high. And where is this measured? And I indicate that it is measured on first floor level. I need to indicate that it's on the first floor level. Otherwise, the contractor will not know that I need to reduce the time for not just the casting of the concrete, but also for the placing of the columns up on that level, because we need to have additional scaffolding and all of that goes into account. That takes that into account. So, because I'm saying that it is on first floor level, the contractor will then know that is where we're going. What are my column sizes? What were the column sizes that we were given? So all the columns were all the columns at 300 by 300, or what were the column sizes? First, we said that all the column sizes on the one side, if you can remember to last week, said that all these columns, all these were 300 by 300, and these were 300 by 400. If my memory serves me correct, that's what we dealt with. Can you not remember? Is it too far gone? Can you not remember? Well, I can remember that. But my columns up there would be 300 by 300. on my first floor level. So I will therefore have a dimension of 4 by 300. That gives me 1200, and my dimensions for my formwork would then be 1.2 by 3 meter by 1, 2, 3, 4, 5, 6 by 6 ohm. Or I can say by 3 by 2. That is for my first floor. And the concrete in those columns would be the exact same, would be the concrete there would be reinforced concrete 25 MPa 19 millimeter stone in my columns, and that would there be my concrete would then be 0.3, 0.3, 0.33 by 6 ohm. That's for my concrete. On that level, important first floor level, it comes at a different cost, and we need to keep it separated from ground to first floor. Okay. Everybody with me? So now I need to measure my slab that is supported by those columns that I've just measured. And in that we would then show that it is the following in a hollow block floor slab. It will be a reinforced concrete 20 MPa in a composite hollow block slab, and I will then work with my overall dimension again, because I know that my thickness of my hollow block slab is 305 millimeter. I know that the overall dimension, because the slab goes into the half, it is 7.8 by 7.9, 7.9 by 7.8 by 0.31. And the 0.31 refers to the 305 millimeter that is now written as in an exponent as meter, rounded up if it exceeds 0.5. So 305 millimeters gives me 0.31 written in meters. So I'm now going to deduct, that is my slab thickness. My slab thickness is there. My slab thickness we know is 305 millimeter thick. So that 305 will give us the 0.31 in thickness as a measurement in meter. But I'm going to deduct for all the blocks that I have. I'm going to deduct for all of those, and we need to now have a look at exactly how we will go about doing this. What do we need to deduct? How many of these do we have? I first and foremost need to decide and look at what the block sizes are that we are given. The block sizes that we are given, I will go back to the drawing in order for us to see that. When I go and I look at this section, I go and I have a look at that section that is shown to us over there. And I look at this drawing and it tells me that I have a slab of 305 millimeter thick. I have that concrete, the top section given to me as 50 and 255 the depth of the height of the block. Also shows me that my blocks are 300 by 230 millimeter terracotta hollow blocks. That 230 would be the length thereof. It also shows me that I have 100 by 230 by 10 millimeter spacing tiles. So when I have to determine exactly what it is that we need to deduct, I need to take into account the 300 and the 230. And of course, I also need to have a look at what it is that we have going further on, and I look and I see that that is in line there, meaning that I have my same 350 millimeters at the end that I had on my previous drawing. So, overall, I will then go and I will say that I would now take my dimension and I have my 800, and I would deduct 2 by 350. That's for all the way around, either side. That gives me 100. A 100, I would then deduct the 230. The 230 that I got from there. And that gives me 30.87, but because I cannot get 0.87, I can say that I have 30 blocks. And I also need to determine how many rows I have. Remember that we have 30 blocks. I need to determine how many rows I have. And for the rows, I will now use the opposite dimension, which is the 900. And I will deduct my 2 by 350, and that gives me 200. For my 200, I will now divide 400. But why 400? Where do I come on the 400? Of course, the width there, from there to there is 300. And my nibs are 100. I need to go into the center there. So I add 2 by 50. And that gives me my 400. When I divide that, it gives me 18 rows. So whatever I do in my deduction here for the blocks, I will work on the size of my blocks that I'm given as 300 by 230. I will then say whatever my dimension is, and the dimension that I've just worked with over here, where I have my block sizes, that are given to us, and I've been given the depth of my block sizes as my block as 255. So it will be the 0.3 by 0.23 by 0.26, because that is 255, and if I write that as meter, it will be 0.26, and multiply by my number of rows of 18, and multiply by the number of blocks per row, which is 30. Okay? Then have my, also need to deduct a 30 blocks multiplied by the 230, which gives me 6 meter 900. That's the length of which I want to have to deduct now. Because I have 18 rows, I'll have 17 blocks in between. 17 rows of blocks. That's 18 nibs that I have, and 18 and 17 rows of blocks in between. So it will be my 6 meter 900 by the 0.1. Where do I get that from? By 0.1 by 0.01, and I need to go back to show where I have that from. Information that I was given these spacer tiles. In the spacer tiles that we have here, it refers to the 100 millimeter, which is there. Oops, maybe I should use a different color. The 100 millimeters, which is there, the 10 millimeter thickness, and that is also under my blocks, and that is why we have the 6 meter 900. It is taken from the 30 blocks multiplied by 230 millimeter thick. Gives me 6 meter 900, my length, multiplied by the 0.1, which refers to that, and multiplied by the 10 millimeter thickness. And there's 17 of those that we would have all the way in between. And I also need to deduct, as you can see here, I also need to deduct, and I need to look at my length of the 7 meter 900, and I deduct the 6 meter 900 from that length that I have overall. That gives me 900. It leaves me overall with 900, and this is now all on the sides where I have to go in and I need to work with, and it's all the spaces that we are needing to determine exactly where we need to measure for these spacing blocks that we need to deduct. It's minuscule. The dimensions that you look at there, 6.9 by 0.1 by 0.01, it is minuscule, but we need to take that into account for my dimensions that I have in order to you look at our spacing tiles, and with the 7 meter 900 that I now need to take into account, which is my length in the opposite direction. And what we have, if you take the 7,800 and you deduct the 6 meter 900 that we had arrived at with the the 30 blocks that we had multiplied by the 230 that gave me the 6,900. So we take my 7,800 and we deduct the 6,900. That then gives us 900, but because we need to work on the other side, it is 450. So it is the length of my So it is over this length of my 7 meter 900 where I will have what goes in between, where the 450 would be on either side. The 450 would be on either side there, multiplied by the 0.01. Because that 10 millimeter is where the spacer tiles will be in, and we will not have concrete in there. And then opposite direction, we would have in between. Why am I drawing it? In the opposite direction, you would then have that from there the 7900 would be for that section there, and in between the 450 in between, or the 400 in between, taking that into account with our spaces that we would have to then deduct concrete in there. But as you can see, the dimensions, if you take that 6.9 multiplied by 0.4 multiplied by 0.01, it's almost negligible. It is 0.06 of a cubic meter. Very little, but we need to take that into account. If you do not take that into account, will the contractor lose money? Will the client lose lots of money in that? Not necessarily, but it's important that we take that. So the spaces, and the spaces being the 10 millimeters the spaces being, the spacing tiles being the 10 millimeter underneath there, it's important that we make note of that. So then, and the formula to the soffit of this, the formula to the soffit of that slab, of that hollow slab, the formula to the soffit of the hollow slab, but composite hollow block slab, exceeding 250, not exceeding 500 thick, including the propping up exceeding 1.5, not exceeding 3.5 meters high above bearing level, you would have our dimension, which is 7,900 multiplied by 7,800. And we then, because of that, we already determined how many blocks we need, determined how many rows we have. It will therefore be, we now need to measure our hollow blocks. And it says there that they are 300 by 230 by 225 millimeter thick cement hollow blocks placed in position, and we have 30 blocks and 18 rows. And we also need to measure the spacer tiles, 100 millimeter wide by 250 millimeters long by 10 millimeters thick, placed in position, and those will be measured in meters, and it will be the 6.9 on the vertical, as per where the ribs are 6.9 meters multiplied by the 17 thereof. And ditto but to the adjacent flush surface, which goes around the outside, along the perimeter, and will be 7.9 by the 0.45 twice, because it goes down over there and over there, and the 6.9 that goes on in between, 6.9 that goes in between by 0.4, and the 0.4 is arrived at the 7,900, deduct 18 by 300 blocks, and deduct the 17 . 17 by the 100 ribs. That gives us 800, and divide that by 2, so that adjacent area then is 400, and that will be the 6.9 by 0.4 times 2 other side. And for my slab, on the side of my slab, for the edge of that slab, I will then have my dimensions of 7 meter 900 along the width multiplied by 0.31 times 2, because it will be this side as well as the other side, and 7.8 times 0.31 times 2. We then also need to, of course, measure the reinforcement that we see in there. We allow an amount of whatever the amount is that we allow for supply and fixing all the steel reinforcement, including cutting, bending, placing in position, allow for the profit and allow for attendance, and that is measured in item. So that, guys, would bring us to the end of measuring this. Now, this is a little bit more intricate, but that we can get as a measure of different sections. It's highly unlikely that in the real life setup that we would get different types of floor slabs, obviously dependent on what the purpose of it all is. Now, please, some questions. Am I talking to myself?
So, can we please go back to formwork where it says extra over formwork for boxing and formwork to soffit of trout slab to form splayed fillet. The 13 there, can you please explain how we get the 13 again?
Okay. Just want to... I'm trying to draw a hand there, Doctor. Okay? Right. Can you remember in first year when you dealt with the measuring of trusses?
Yes, sir.
Okay. Right. Now, if you have a look at what are these red circles that I've done there. These red circles would illustrate the troughs. Okay? And when you look at that hand that is shown there, if this illustrates the troughs, how many of those boxing in sections would you have when looking at that drawing on the taking it into account as well? Then this would refer to a different color. Would refer to that. How many black dots do you see there? You see? 1, 2, 3, 4. Right? And how many red circles do you see there? 1, 2, 3. What does it say to you? It says to me that for every trough I have, I should have one more rib. You hear what I'm saying, Doctor?
Yes, sir.
Do you now understand where we get the 13 from? Because we calculated and we determined that there were 12 ribs. Okay? So if these are if there are 12 ribs, or troughs, 12 troughs. If those are the troughs, how many ribs would there be? Or how many of these boxing in sections would there be? And if I can blow this up, you can see there, if that is the trough, if this is the trough, and we show where those fillets should be, can you see that there is one more, because the number of the troughs, we added one as it would reflect that we need to have the fillets on the outer side of each and every trough. You see that, Mamta?
Yes, sir.
Does that make sense to you?
Yes, it does. Thank you, sir.
Okay. Anyone else?
Okay, sir. I also have a question.
Who's that? Trisbee.
Yes, sir. Sir, this concept about the spacing tiles, I didn't understand it so because what is this spacing tiles?
Okay, Trisbee, let's have a look there. The spacing tiles is not really a concept that is really being used. If you have a look at what we've done previously, the spacing tiles, as you go at the bottom there, as I was indicated earlier, if you do not measure it, I will not penalize you if you do not measure it. It is spacing tiles. It's what goes in between, ensuring that the concrete and with all the hollow blocks and that it does not stick, and that we can strip out the formwork properly and all of that. So if you do not measure those, if you only measure the reduction of the blocks, I'll be happy with that. I will not penalize you because of that.
So it's not tiles exactly, sir?
No, it's not tiles. It's just spacing tiles. A spacer. You know what a spacer is?
Yes, sir.
So it's like spacers that we put in there to ensure that it stays in place, that we do not lose, or that we do not that it does not stick and all of that. So it's basically to ensure that our thickness remains the same and.
Okay, thank you, sir. I understand.
Okay. Anyone else? Well, what I can also say is that next week's test will not have an intricate drawing such as this one. That much I can say. Anyone else? Okay, are we okay? I actually have been needing to get to a bathroom, but I thought let us finish this off first. If there's no one else, guys, I want to wish you well. You guys are writing test tomorrow, by the way, with Miss Van der Merwe.
Yes, they were writing test.
Okay. No, guys, that's great, guys. You have got my email. You guys have my cell phone number. You can send me queries that you might have for next week. And wish you well and stay safe. Please, guys, our numbers are increasing. Our numbers on campus at the institution are increasing. Please